Hello everyone. Today we are going to see the lecture on single phase half wave AC to DC converter with RL load. Previous class which we have discussed that single phase half wave rectifier AC to DC converter with R load. Now in the present class we are going to see the single phase half wave rectifier with RL load. We are going to see the difference. What is the difference between R load and RL load? It is nothing but here we are going most of the human household applications all are inductive loads. That is the reason we are going to refer the RL load condition now. Now let us see circuit diagram of the single phase half wave AC to DC converter with RL load. First, we will draw the circuit diagram. What is the circuit diagram here? Now, one source we will take, one source we will take here, one source here we will take, that is one source we will take here, one source, and after that, here half wave means we are going to take it as a half wave rectifier circuit. Here, thyristors we are going to use, and after that, there is a resistance or as well as inductor. We are going to take it as a load and we are going to connect it like this. Now we are going to observe Vs supply voltage. Vs is equal to Vm sine omega t. Here, basically single phase supply. That is, as we know that single phase supply 230 volts, 50 hertz. That only we have mentioned over here. And now coming to that, here we are going to take it as a sinusoidal waveform. Let us take it as a one sine complete sine waveform. So this is the positive half cycle and this is the negative half cycle. That is called this is positive and this is negative half cycle. Now coming to that, come to the thyristors. Here, what is this? Anode. And coming to that, next this is cathode and after that this is the gate pulse. As we know that we are going to apply gate pulses like 0 1 0 1 0 1 we will apply. Now coming to that, here R load, that is called R naught, we will indicate, and voltage drop across it is VR naught. And coming to that inductive load, that is L naught, voltage across it is VL naught, and the current flowing through the circuit it is I naught. So suppose if you observe that the total voltage appeared across this load, it is, we can write it as V naught is equal to I naught into R naught plus L into di naught by dt. This is the general derivation of the output voltage of the single phase half wave AC to DC converter with RL load. Now coming to that, here inductive load it is came to the condition that is due to that the inductive current whenever the positive half cycle is going to end, but the inductor it will supply the energy to the thyristor. Due to that, there is a extension of the supply will come in this single phase half wave AC to DC converter with RL load. How it will come, we will see now step by step. We will explain that how it is going to come. Everything I will explain. Now draw just now draw the now draw one vertical line. Now this is not coming properly. That is why I'll erase it. Now we will draw the one vertical line. That is, we will take it as a this line. We will use it here. These are the different colors. Let us draw the let us draw the vertical line with slowly draw vertical line in order to derive the output voltage, output current, and RMS voltage, RMS current, everything we will derive. Now, first, this horizontal cycle divided into multiple parts so that you can combine the every positive half cycle. Next, this one. After that, take this one. Now from here to here, slowly you include this. That is one positive half cycle. This is one negative half cycle. Again, this is one positive half cycle. Again, this is one negative half cycle. And we are going to connect it like this. And again, we are going to take it as a another half cycle. Now let us take it as a this is 0 and this is 180 and this is 2 pi and this is 3 pi and this is 4 pi and this is 5 pi. Take it as a this one in terms of omega t, that is in terms of seconds. We can take it here. Now this is the peak supply voltage, that is Vm. We will indicate here, and here let us take it as a first. What we can assume here, first we will assume that when the supply to duty cycle, let us take it as a when we are going to derive, first we will take 30-degree phase duration. This is omega t at alpha is equal to 30 degree. Firing angle is 30 degree. Now second one we will take, second cycle we will take. Before that we will observe the current value also. That is why we will take it as a alpha 30 degree. Here voltage and current waveforms are not similar because the reason is here inductive current, it will slowly charge the current, that is equal to the output current. That thing we have to mention over here. Now let us take it as a switching pulse. Here let us take it as a alpha is equal to 30 degree. This is the switching pulse which I am going to give it to the thyristor. That is why I am indicating here one highlighted color. Here negative we are not going to conduct. Again here this is the positive, again 30 cycle duration. And again here negative we are not going to control. Again here there is a 30-degree duration. So let us take it as a this is alpha is equal to 30 degree triggering angle, firing angle. So this firing angle, parallelly you draw one line which indicates the V naught and I naught. Indicate like this. Next, one more 180 degree. You draw a line so that the pulses will appear here. Next, this one 2 pi you draw a line. We have to be we have to draw all the lines in a very clear manner so that there is no overlapping in between one cycle to another cycle. This is the basic fundamental thing. Now this is again 3 pi. You draw one more vertical line and 4 pi also one more line you can draw. We'll see up to 4 pi. Now what is happening here? We are going to trigger the thyristors here from here in this position. Exactly in this position I am going to cut it, and after that the thyristor is going to switch on from alpha is equal to 30 degree. From alpha is equal to 30 degree. This is current, but here inductor it will go from 0 level to 180 level, starting up to this it will move up to 180, that is pi. We'll take it as a pi value. And coming to the voltage, it will come up to like this. And after that, here the major concern is up to this position, up to from alpha to pi, inductor charge the energy. Inductor charge the energy. This charged energy, it will get discharged up to certain time duration. So that is the reason. So we can't say that the inductor energy is exactly, it is going to be 0 here in this position. That is why what we are going to do here, we are going to draw the inductor current from alpha to up to, so inductor current from alpha to up to this position, it is get charging, and after that it will be discharged. Let us take it as a this firing angle will be beta. Now up to this position inductor operation will complete, and the existed output voltage will be up to from pi to beta. So up to this there is no voltage. Now again up to when we are going to switch on the thyristor, again it will be 0. similar waveform, similar repetition will come and it will go like this and it will get charged. And after that, it will go up to beta value. This beta, this duration will come due to the inductor discharge. Inductor it is going to discharge in this place. That is the reason this duration is coming. Now from here to here, again it will be a zero. Again slowly it will get charged, and after reaching 2 pi, it will get discharged up to 2 pi plus b 3 pi plus beta. So this is the operation, it is going to still continue. This is the V naught value and this is the I naught value. When this is alpha is equal to 30 degree. Suppose you can increase the alpha is equal to 60 degree, alpha is equal to 70 degree, like that you can increase. The thing is here positive cycle of the supply will reduce it and negative cycle of the supply will be improved. It means from this we can give one clear instruction that alpha is increasing, alpha 1 is greater than, sorry, alpha 3, let us take it as alpha 3, greater than alpha 2 is greater than alpha 1. Then what will be the voltage value of positive output voltage value will be positive output voltage value will be that, let us take it as a V3 less than V2 less than V1. It means if you observe that alpha is increasing, alpha 1 to alpha 1, alpha 2, alpha 3. Alpha is increasing, output voltage automatically try to reduce it. That is the thing we can observe over here. Now coming to the how thyristor voltage is appearing across these overall waveform, we'll see now. From here to here, thyristor is conducting from 0 to alpha. Thyristor is not going to conduct because we are not going to give any triggering pulse. Then alpha to beta, it is not going to conduct. Then beta to 2 pi, it will not conduct. That is why it will, the waveform will be like this. And after that, it is conducting from here to here. Again, it will be a zero waveform up to this. And after that, there will be a waveform. So this is the thyristor VT value. Up to this, we are not going to reach. Beta value, we are not going to reach. And only negative half cycle only, it will come to the condition. This is the way we can observe. So first to positive half cycle 0 to alpha, it won't conduct. From alpha to beta, it will conduct. From beta to 2 pi plus alpha, it won't conduct. From 2 pi plus alpha to 3 pi plus beta, it will conduct. So that is why I indicated here the waveform. And after that, 3 pi plus beta, it will again is going to switch off. That is why I indicated a voltage here. Now, when we are going to derive here, average output voltage, RMS output voltage, we have to derive for each repetition of the cycle. From here to here, one repetition, and after that, from here to here, another repetition. So, complete repetition is coming from every 2 pi angle duration. So, based on this, we are going to observe that V naught RMS or V naught average will be calculated from 0 to 2 pi. So, that thing we can observe in the average voltage duration. Now, if you observe that V naught average is equal to 1 by 2 pi times of integration alpha to beta Vs, it is nothing but Vm sin omega t. For your clear understanding, I will write from the starting. So from some 1 by 2 pi, Vs, it is nothing but, let us take it as a source voltage. Vs is equal to Vm sin omega t. So Vs is equal to Vm sin omega t. Let us take it as a Vm sin omega t. Now take it as Vm by 2 pi integration alpha to beta sin omega t d omega t. Here differentiation of integration will be with respect to omega t. Then that is the case Vm by 2 pi integration of sine, it is nothing but minus cos omega t integration alpha to beta. Now go to the final derivation, that is V naught average is equal to minus, take it as a common, minus Vm by 2 pi Apply both the side integration the limits cos beta minus cos alpha. That is, suppose now apply minus out inside of the thing, then that is the case. Minus Vm minus will be applied over here. Then cos alpha minus cos beta. This is the V naught average. So coming to this, after the V naught average, we will derive the RMS voltage. And here V naught average, how we will write here? V naught average is equal to I naught into R naught plus L into L naught d I naught by dt. Like that we will write it in the expressions. So this is the second expression. Now if you observe that the derivation of the V naught RMS will be previous whatever the way we have discussed. Now here also V naught RMS we will discuss. Now V naught root means square value. V naught RMS is equal to square root of 1 by 2 pi integration alpha to beta Vm sine omega t d omega t. Then Vm take it as a common Vm by 2 pi. Here RMS means we have to make it as a square. Then Vm square by 2 pi. So sine squared theta, as we know that, how can we write sine squared theta? Sine squared theta is equal to 1 minus cos 2 theta by 2. So this thing we will submit it over here. 1 minus cos 2 theta by 2. This is everything will be 1. Then integration alpha to beta d omega t. Next, square root means Vm, we will take it as a outside. Here 2 into 2, 4 jar, that will also, it will come 2. And after that, square root of pi, square root of, take it separate, then that is, then you will get easy understanding. Integration alpha to beta d omega t minus integration alpha to beta cos 2 theta d omega t. 2 theta it is nothing but 2 omega t. So this is the way we can write it here. Next, if you observe that, then take it as a next direction, that is Vm by 2 root pi square root of integration of alpha to beta d omega t is nothing but omega t. Let us take it as a integration alpha to beta. Integration of cos 2 theta is nothing but sine 2 theta by 2 integration alpha to beta. Then Vm by 2 root pi square root of beta minus alpha minus sine 2 beta minus sine 2 alpha is divided by 2. Apply minus inside, then that is the case Vm by 2 root pi square root of beta minus alpha plus sine 2 alpha minus sine 2 beta is divided by 2. This is the V naught RMS. Then suppose here what I said, that thyristor inductor current, it is inductor current, it is coming from alpha to beta. Suppose the selected inductor value is very high to deliver to deliver the inductor current, to deliver the inductor current from alpha to 5 plus alpha. Then that is the case. V naught RMS, V average, everything we will change. Now we will see how the output voltage, average output current, average output voltage, and RMS output voltage, everything we'll see. Now suppose The inductor, it will deliver the energy from alpha to pi plus alpha. Then what is the output, average output voltage value? We'll see now. Suppose V naught RMS, as we know that we will discuss now. V naught V naught average we will take first. V naught average is equal to, here complete repetition. Halfway means one complete repetition we have to take. Then that is the case 1 by 2 pi integration of alpha to pi plus alpha Vm sine omega t d omega t, because here utilized selected inductor value is very high. Inductor value is very high. Due to that, the waveform, whatever the waveform it is there, it will go from alpha to pi plus alpha. That is the reason I indicated here alpha to pi plus alpha. Now Vm by 2 pi integration of sine theta. Integration of sine theta. What is integration of sine theta? Minus cos omega t. Integration. Apply both the side. Pi plus alpha. Here, if you take it minus outside, minus Vm by 2 pi cos omega t integration of alpha to pi plus alpha. Then here apply this. Then V naught average is equal to, minus will be taken as outside, minus Vm by 2 pi cos pi plus alpha minus cos alpha. Cos 180 plus theta, how can we write? Minus cos theta, right? Then that is the case, minus Vm by 2 pi minus cos alpha minus cos alpha. Then how will come here? Minus, if you apply here, minus will get cancelled. This minus will get cancelled. Vm by 2 pi 2 cos alpha. 2 will get cancelled. Finally, we will get it that V naught average is equal to Vm by pi cos alpha. When the selected inductor value is very high, the V naught average will be Vm by pi into 1 plus cos alpha. So we can see the comparison here, previous one and this one. The inductor energy, based on the inductor energy only, average output voltage V naught average will be completely varies from one angle to another angle. And coming to the next, sir, let now we will see V naught RMS differentiation for inductor value is selected very high. Now we will take it as a V naught RMS is equal to square root of 1 by 2 pi integration alpha to pi plus alpha Vm square sine square omega t d omega t. Then this case, take it as a Vm will be common, square root means square root will get cancelled. Then here we can write it here root 2 pi. And after that, as we know already, we written that sine square theta means 1 minus cos 2 theta by 2. That is 1 minus cos 2 omega 2 by 2. Here integrations are alpha to pi plus alpha. Let us take it as a d omega t. Now again we will take it as a 2 will be outside, then Vm by 2 root pi square root of. Let us take it as a step by step now. Integration alpha to pi plus alpha d omega t minus alpha to pi plus alpha cos 2 omega t d omega t. Now we will take it this one Vm by 2 root pi. Take it as pi plus alpha minus alpha. Alpha will get cancelled. Then sine 2 omega t by 2 integrations cos 2 theta means sine 2 theta by 2. Here take it as alpha to pi plus alpha integration. So alpha to pi plus alpha. Finally, final waveform, finally, V naught RMS, we will take it as a, let us take it as a Vm by 2 root pi square root of pi minus, let us take it as a sine 2 omega t means pi plus alpha minus sine 2 alpha by 2. If you observe this is the way it will come. Now we'll see how what is 2 pi plus alpha, everything we'll see now. Now in this derivation, we'll see this again now. We'll go through this. How we are going to vary the RMS voltage with respect to time interval, everything. Now we'll see this. This is the derivation we can see. Yeah. Now observe that V naught, first we will see sine this part. So whatever this part we will see first. Sine 2 pi plus alpha. How we can write it this one? Sine 2 pi plus sine 2 pi sine 2 pi plus 2 alpha, like that we can write. Sine 2 pi plus sine 2 pi plus 2 alpha. Then write down this sine a plus b. Sine 2 into pi plus alpha, right? Sine 2 pi plus 2 alpha. Sine a plus b, what we can write? Sine a plus b, sine a, sine a cos b, sine a cos b, sine a plus b, sine a plus b, sine a cos b minus or otherwise we can write it like this: sine 2 theta plus sine 2 pi plus theta. How can we write it this? Sine 2 pi plus theta cos 2 theta we can write directly. So otherwise, instead of otherwise you can go through that sine a plus b also, but here we can take it as a 1 minute. Here we can take it this sine a cos b plus cos a sin b. Let us take it as a cos 2 pi cos sin 2 alpha. Sin 2 pi means 0. Cos 2 pi, how can we write it? Cos 2 pi. Cos 2 pi is 1. Then how we can write it here? Sin 2 pi plus 2 alpha, that is equal to sin 2 alpha. Now sin 2 alpha it is there, right? If you submit it in this, what it will come here? Real value, final value we'll see now. Now I'll rough it this derivation, little rough it. Then we'll see how we are going to do after, how we are going to see the final derivation of the RMS voltage. Now, how you can write it here? V naught RMS is equal to Vm pi 2 root pi square root of phi minus sine 2 alpha minus sine 2 alpha by 2. This one will get cancelled. This finally how it will come? Let us take it as a Vm by 2 root pi square root of 5. So how we will get it that? Finally sin a plus b means sin a cos b plus cos a sin b. Sin 2 alpha will get cancelled. V naught RMS is equal to Vm by, then that is the case, how it will come here? Pi minus sin 2 alpha, sin 2 pi plus alpha, sin 2 alpha, sin 2 alpha will get cancelled. This 1 by 2 will be there. Then that is the case. How can we write it that? Root pi cancel. Then Vm by 2 will be there. So this is the basic information which we have obtained. Now square root here also square root will be there. Square root of things is there. Here 2 is there 2, but this entire thing will get cancelled. 2 will get cancelled. We not RMS is equal to Vm by 2. So this is the basic expression for the V naught RMS. Now coming to the next, we will observe that P naught average, that is P naught average is equal to V naught average into I naught average. Next, P naught RMS is equal to V naught RMS into I naught RMS. So by substituting these two values, we will get the average power as well as RMS power. Both the power will get it here. So this is the final expression when we are going to obtain for the single phase half wave AC to DC converter for RL load. Thank you.